What's up, YouTube? This video, I'm going to run through pile designs. So, if you know what piles are, but you're not really sure when to use them or how to design them, hang around and I'll show you how. So, in this video, I'm going to quickly run through what is a pile, when to use a pile, how do they fail. We're going to run through how to design it for vertical loads, for lateral loads, and also how to actually build them out on site. So, what is a pile? It is part of the foundation. And when we look at foundations, people typically refer to two different types of foundations. They look at shallow foundations and deep foundations. Piles form under the latter, being a deep foundation. And there's a little snip of it on the right hand side. So, again, to elaborate on what a pile is, it forms part of the foundation. And when we think what the purpose of the foundation is or the substructure, it is to transfer the load safely from the substructure to the supporting founding material, which may be soil or rock. So a typical question is when to actually use a pile. If we're looking at shallow foundations or deep foundations, as a rule of thumb, you should typically just always try to go for a shallow foundation first because they're cheaper. You don't need to bring out a piling rig on site, and it's easier to get a larger surface area with strip footings, pad footings, and raft footings. But sometimes the ground conditions at the surface aren't as good as the ground conditions lower down. So if the ground conditions at the higher levels aren't suitable and there's rock deeper down, that's when you would use a pile. But as a rule of thumb, try and go with a shallow foundation first because it's more economical. And if not, then use a deeper foundation. So, like anything in structural design, we have to have an appreciation of how elements can fail. Foundations, including piles, can fail in three main ways. Firstly, it's the ground fails. So you might exceed the bearing capacity and you've got, the pile itself is intact, but the ground has failed. The next thing to check is the pile itself. You might be bearing on a really firm material like rock, and the pile can fail, the structure itself, that is. And then finally, it could be a stability issue. So the pile could actually be in uplift and it moves. So the ground's not failing, the pile's not failing, but it is a stability issue when the pile is moving. So how does a pile resist vertical loads and take them into the ground? There are two components here that I've really simply sketched on the page here. Firstly, there's skin friction, which is the friction on the side of the pile. And secondly, there's end bearing. So people will sometimes refer to piles as being end bearing, which means they've just designed for the base of the pile, which could be generally in rock, and they've ignored the softer soils above, or it could be the skin friction on the side. In reality, it's generally a combination of the two. So I'm sharing at the moment a calc of the how to calculate one of the various ways to calculate the skin friction on the side of a pile. As you can see, it's a bit of a headache. In my personal opinion, I prefer to leave that to a spreadsheet or a verified software. If I'm just doing a hand calc, I'd much prefer to identify a layer of rock and consider it end bearing and just work out the end bearing capacity for my pile and essentially ignore the skin friction to avoid dealing with this. So sometimes piles not only resist vertical loads, say gravity loads, but they also have to resist uplift. Here's a sketch in terms of how you can see that happening. On the left-hand side, it's neutral in terms of you've got this dock and um, there's groundwater pressure above and below that slab. And then if you were to drain that dock, you would have buoyancy underneath. And those piles are now essentially in tension, resisting uplift. So when it's in tension, there is no end bearing and you're relying fully on friction. So you can't really do what I just said before and avoid the and just make an assumption about end bearing. That's only for the gravity loads. So yeah, just to highlight that sometimes piles, when they're resisting uplift, they have to be in tension and they will be purely on the skin friction. So this sketch here shows what happens in reality for most vertical loads on pile in the fact that they're taking both side friction and end bearing. So initially the load on the pile, the initial resistance will be the side friction, and then that side friction will get to a point where it's got its maximum capacity, if you will, And then once that all that load will continue as the load increases to the end bearing, and at some point the end bearing will reach its maximum capacity as well. So if your pile is in a rock and you've worked out the sort of maximum bearing capacity, the chances are that pile in the ground, now we've satisfied that we know what the allowable bearing capacities are, and we're not going to exceed that. The next step is to check the actual element itself, and it's the exact same as a column. So a pile, once you've satisfied the ground condition check, when you're checking the element, it is the same as a column, which is what I've sort of highlighted in the text here, and I've drawn a very ugly column interaction diagram. How a pile behaves when resisting lateral loads in the ground is a bit tricky to work out by hand because it depends on the interaction of the pile stiffness relative to the soil stiffness. When we're talking about lateral loads, people typically talk about short piles and long piles, and to distinguish it between the two, it really depends on how they fail. So, as a rule of thumb, I think it's something around the lines of 10 times the diameter would mean anything shorter than that is a short pile, anything longer is a long pile. So short piles are really defined by the way they fail, and that's that the pile doesn't fail by bending, it fails by the whole element sort of rotates. On the left-hand side is a free head pile, on the right-hand side is when you've got a fixed head pile with a pile cap. And yeah, it's essentially the pile is too short to develop a plastic hinge where the maximum bending moment is experienced. Now, longer piles, as you can see here, they do fail when by like a plastic hinge, if you will, where they're experiencing their maximum bending moment. And again, these bending moments are very difficult to work out. Sort of like, it's not doing WS Golden A like a simply supported beam. It is dependent on the relationship of the stiffness of the pile to the stiffness of the soil. So I think it's good to know how the soil reacts and, be able to sketch the basic sort of like bending moment profiles for this stuff. But in my opinion, and yeah, comment if you disagree, I wouldn't be trying to work out these moments like just by hand. That's something that's best left to the computer. And you'll see when you open up some analysis packages, you'll have to make some assumptions anyway. So there's a bunch of different ways to estimate this stuff. And it's good to know how the soil and the pile behave. But yeah, working this out by hand is pretty tricky stuff. There are three main ways to install a pile. I'll just quickly go through the pros and cons of each of them. I'm also focusing on concrete piles here. You can use steel and timber, but concrete is, from my experience, by far the most common. So, firstly, you can drive piles, and that is good because you don't have to wait for the pile to cure. It is already cured because it's precast. So, in a sense, that's faster. The downside of it is it causes a lot of noise and vibration, so it might not be suitable in urban areas. The second method is CFA, and that's essentially when you drill into the ground and as you're lifting up the auger, you're injecting concrete. So that's good when you're worried about the stability of the soil sort of like collapsing in on itself, which is more likely to happen around like higher groundwater tables. Um, and then the final one is a board pile. So that's what I'm showing on the screen here. That's when you drill into the ground and you create a void. And you have to check to make sure that it's suitable. You might need a temporary liner as well to make sure the void doesn't collapse in on itself. Then you come in and you lift a reinforcing cage and you drop that into the hole. And then you insert concrete via a tremie. And on the bottom right here, you can see the end product, which is a reinforcement cage. Well, it is the board pile. So that's Piles 101. If you've got any questions, drop it in the comments. If you like this, give it a like and subscribe.